All right, everybody proofs, and that's what they do. Everyone proofs is actually the name of the series. That's all right. Everybody proofs is fine too. They all mean the same thing. We're going to talk a little bit about those angle addition postulates that we love so very much. Let's start out by looking at. I lost it. Let's start out by looking at one that we can fill in. Okay, we have. Let's see what's going on. We have these three pictures. Angle 1 and angle 3 are complementary, which means angle 1 and angle 3 add up to 90 degrees. That's good. So these two are 90. I'm just going to write that off to the side. That's my rough draft, so to speak. We also are given that 2 and 3 are 90 degrees. So honestly, and I didn't look at this proof ahead of time. Kind of just go for it because I feel it's more authentic that way. I look at stuff like this, and when it says stuff like that, and I have to prove that 1 and 2 are equal, usually what I'm doing, and again, this is going to be a rough draft, I could say stuff like 1 plus 3 equals 90. And then that also means 2 plus 3 equals 90. Those are my givens. And so since 1 plus 3 is 90 and 2 plus 3 is 90, that means 1 plus 3 equals 2 plus 3, transitive property. And then after I subtract 3 from both sides, I get 1 equals 2, which is what I'm trying to prove. Okay, and that's eventually what I'm getting to. So again, I'm sure this proof is that's a lot of steps. That seems like a lot of steps, but maybe there's just pickiness there. I'm not sure. But again, I'm given something. And then usually what's going to have to happen is I have to say the definition of congruence and stuff like that. So that's probably the main thing. So step number A, 1 and 3 are complementary, 2 and 3 are complementary. That's my given. Okay? Step B is 1 and 3 add up to 90. I said that. 2 and 3 add up to 90. I said that over here too. And so I would say that that's the definition of complementary. Your book likes to use, I think it's called complementary angles theorem. No, congruent complements theorem. It's all good. It's all the same. I mean, if I'm going to follow the book, congruent complements theorem. It's not necessary complements theorem. Again, if I forget the name of that, there's nothing wrong with me saying the definition of complementary angles. Okay. Step 3 is what I did right here before I crossed out my 3. Step C, is what I did over here before I crossed out my 3s. And if something equals 90 and if something else equals 90, that's the transitive property. Reflexive property is something that I personally rarely use. But what it means is something equals itself. So I think what this wants you to do is this wants you to acknowledge that 3 equals 3. We know that, and it's pointless. However, this proof wants me to acknowledge that and be like, hey, remember, 3 equals 3. So reflexive property is a rarely used property, but what it means is something equals itself. So what they want me to say is that I can use C and then say something equals itself. Well, 3 equals itself, no duh. But after not acknowledging that 3 equals itself, I can subtract 3 from both sides using the subtraction property. Subtraction property of equality, but I think at this point we can now just say subtraction property. And if I can say the measure of angle 1 equals the measure of angle 2, then angle 1 is congruent to angle 2, and that's the definition of congruence. Now, again, before doing this problem, I didn't look at this problem. Like I said, I kind of like to go into these blind a little bit and arrive at a conclusion. Sometimes that gets me into trouble. Sometimes I sit there and go like, because proofs are not, a typical mathematical process where one step obviously leads to another. Sometimes you have to think, and sometimes it's not obvious. But with the angle addition postulate type problems, even though this is really not that, it does use the idea that two angles add up to each other. So usually with these types of problems, with angles that add up to equal something else, you could usually at some point say that it equals each other, and you could subtract and kill things off, and that's good. So that is the fill in the blank one. That's problem 6. All right, here we are to write a 2-column proof based off of that picture right there. I have all this space over here, but I'm still going to go to my tried and true Post-it notes. What am I given? I'm given that 4 equals 7. So so based off of my given, I could say 4 equals 7. Okay, again, this is a rough draft. I know that this is not what my proof is going to look like, but this will help me figure things out. That's all I know, so I don't know why I put that comma there. What I also can say is 4 equals 5. And that 6 equals 7. Why can I say that? Hold on, let me do another thing. That's vertical angles, baby. Vertical angles are congruent to each other. So I could say by definition of vertical angles that these guys are equal to each other. All right, what am I trying to prove? I'm trying to get 5 equal to 6. So I have to make my connections here. I have to make 5 equal 6. So here's an idea. This is another very simple proof. If I use substitution, I can turn 4 into 7. So 4 is going to become 7, so I could say 7 equals 5. So if 7 equals 5 and 7 equals 6, then 5 equals 6. And that's what I'm trying to prove. And so I did that using the transitive property. So obviously, I have a little bit of work to do. When I do this guy, I have to remember the measure of angle 4 equals, and so that's, definition of congruence. And before I end, I have to turn the measure of angle 5 equals the measure of angle 6 into angle 5 is congruent to angle 6, and that's also the definition of congruence. So I should be able to say, given step 1, step 2, step 3, step 4, step 5. No. Given step 2, step 3, step 4, step 5, step 6. I should be able to do this in 6 steps. So let me put that there. Let me draw out my statements. My reasons. Statement number 1. Angle 4 is congruent to angle 7. That's my given. Always start out with the given. Because angle 4 is congruent to angle 7, I can say the measure of angle 4 equals the measure of angle 7. And I know in my scraps I just said 4 equals 7, but when I completely make my 2-column proof, I can't just be lazy. I can be lazy for my rough draft. Not congruent, is equal to the measure of angle 7. And that's by definition of, how much space do I have? Congruence. Let me adjust my focus a little bit. That's better. That's better. The office. All right, so what did I do next? I looked at my picture and I saw that 4 and 5 are vertical to each other, and I saw that 6 and 7 are vertical to each other. So the measure of angle 4 is equal to the measure of angle 5. Also, the measure of angle 6 is equal to the measure of angle 7. And I'm using the definition of vertical angles. Again, there's probably a postulate or a theorem in the book that's called like vertical angles congruence theorem or something like that. And that's fine. This is fine too. I just don't feel like flipping through the pages of my book and saying, what's the exact name of this thing? I don't have to do that. All I have to do is say the definition of vertical angles, because my book might use what I literally just said, but another book might have a special name for it, because it's not like these books are written in the Bible, or these things are written in the Bible somewhere. They're just written in a book. The Bible, of course, being my favorite book because it contains like 66 separate books put into one. All right. I also said that 7 equals 5. 7 equals 5 because, why did I say that? Substitution property? Oh, yeah. Because in the original given, I had 4 equals 7. And so I'm going to change that 4 into 7. So the measure of angle 4 equals the measure of angle 7 using the substitution property. My goal is to get 5 equal to 6. What did I do wrong here? What was I supposed to write out? I was supposed to say 7 equals 5. And I wrote out 4 equals 7. I wrote out the original. Watch what I can do. Permanent marker fixes everything. The measure of angle 7 equals the measure of angle 5. Look, now you can't tell the difference. All right, so because 7 equals 5 and 6 equals 7, since 6 equals 7 and 5 equals 7, then 6 equals 5, or in this case, 5 equals 6. So I could say the measure of angle 5 equals the measure of angle 6. That's the transitive property. And then if measure of angle 5 equals the measure of angle 6, that just means angle 5 is congruent to angle 6, and that is the definition of congruent. Hey, perfect, except for that permanent marker thing. The great permanent marker fiasco of 2020. Easily the worst part of 2020 that I can remember. Just kidding, pandemic. There it is. Angle ABC is a right angle, which means by definition of a right angle, ABC equals 90. So that whole thing is 90. ABD and CBD are complementary. That's what I'm trying to prove. It seems, again, like this is almost too easy, but I have to show my steps. So if this would be step 1, this would be step 2, and that's definition of right angle. Then, of course, I'd use the measure of thing by the angle. So I need to arrive at ABD and CBD. So I have to find a way to try to connect ABD and CBD to this guy that I wrote up here. What you're always trying to do is see if you can build a connection between that guy and that guy. And the connection that I can build is ABD plus CBD equals ABC. And this is the angle addition postulate. The app. Ooh, throw an R in there and my dad would love it. AARP. American Association for Retired Persons. Okay. I liked that one. All right, well, I already know that ABC is 90, so why don't I turn this into ABD plus CBD equals 90? How do I know that? Because ABC is 90, and so I just turned ABC into 90 using substitution. Subs. And that just means that they're complementary by definition of complementary. So it looks like we have a given. We have step 2, step 3, step 4, step 5. Not bad again. Not bad again. So let me put this here. Let me write my proof. I feel like I should have more space here, so I'll do this. Statements, reasons. Statement number 1 is ABC is a right angle. It's my given. By using that phrase, I can then say that the measure of angle ABC is 90. The measure of angle ABC equals 90. And that is the definition of a right angle. Definition of a right angle. Step 3 is using the angle addition postulate. Again, my job is to build a connection from that to that. And so ABC is the same thing as those two guys added together. So I can say the measure of angle ABD plus the measure of angle CBD equals the measure of angle ABC. And that is the angle addition postulate. Funny, that's the first time in these 3 proofs that I used that. I feel like with the segment addition postulate, I use that all the time. Maybe I don't know. Maybe I just did a whole lot more proofs, but I feel like that should be used more often than not, and it hasn't really been. Look at that. So if ABC is 90, then I'm just going to turn that ABC into 90 because that's going to help me figure that out. So 4 was the measure of ABD plus the measure of angle CBD equals 90, and I did that using the substitution property. My goal was to prove that ABD and CBD are complementary, so I can now say that ABD and CBD are complementary. And the book likes to use the reason. And again, it's just such a wordy thing that I don't remember what it's called. It's like complement angle congruence postulate. It's an awful name. Congruent complements theorem. So I can use congruent complements theorem, and maybe I will, just to be consistent with what McGraw-Hill does. Congruent complements theorem. But again, I would prefer to say, and again, because I simply won't remember it otherwise, I would much rather say something to the effect of the definition of complementary angles. All right, so there it is. Can you see it? Yeah, now you can. 3 proofs involving angles. That was fun. All right, bye.